Thank you very much. I hope you can hear me well.
Yes, we can hear
Um,
you very well.
Great. It's truly a pleasure to be with you. Unfortunately, only virtually, but I hope we'll continue to have opportunities to exchange ways that we can help manage the health and particularly prevent the long-term consequences of what we recommend to infants and children, especially as it relates to early nutrition. The topic today is going to be relatively more pointed into looking and seeking at specific areas as it relates to nutrition in early life and what the long-term consequences of this. And we'll be talking specifically on the role that the protein in the diet of an infant has an impact on these. It is absolutely clear that from the evolutionary point of view, breastfeeding has and always has been the standard by which we provide the infant what is appropriately, evolutionarily speaking, to be able to survive in the best possible way. But it is increasingly clear that breastfeeding and breast milk are not just a way to provide nutrition, but are ways that the growing and developing infant receives food from the environment to provide actual functional benefits that go beyond just protein, carbohydrates, fat, and micronutrients, and helps develop gastrointestinal, metabolic, immunologic, and neuro and psychosocial components to the development of the infant. Now, as it relates to nutrition, as most of you know, we've made tremendous gains just in the last 20 years. When we look at stunting, which is the closest marker for a child getting adequate energy and protein, we have reduced stunting or low height in infants and children by two-thirds compared to where we were just 20 years ago. More than 54 million less stunted children compared to the year 2000. Unfortunately, as a consequence, we also see what appears to be small but is significant increase in the percent of children that are overweight. And this has continued increasing, unfortunately, and particularly in absolute numbers in developing countries. But this increase in overweight signifies not only children are getting enough calorie and protein, but probably more than they require. Now, when we look at the global picture of body mass index in the last 50 years, so uh, this is starting at 1980 all the way to 2020. The bottom two blue sections are the prevalence of underweight children, adolescents, and adults that has continued decreasing. Since the year 2000, we have continued decreasing the percentage of children with undernutrition. However, there has been a significant and faster increase in the percent of the global population that is either overweight or obese. And globally, obesity and overweight have overcome now moderate and severe underweight. We have more overweight and obese adults in the world than we have adults with low BMI or malnutrition. And when it comes to children, as of the last 2 years, we have more obese and underweight children of school age in the world than adults. So it is becoming clear that this problem has continued. Despite our improvements in undernutrition, we continue to have a significant increase in overweight and obesity, which results in this rise of non-communicable disease. Today, non-communicable disease will kill 40 million people a year. 71% of all deaths worldwide today are due to overweight, obesity, cardiovascular, and consequences of that, including cardiovascular disease, cancer, as well as persistent allergies and inflammatory diseases. So this has become clearly a major health problem. And when we look at what are the top global factors that risk increased mortality, so this is mortality and years less of life, the top ones include high blood pressure, dietary risks overall, which result in high plasma glucose, high BMI, high cholesterol. There still is a risk of undernutrition, which used to be number one. Today, that risk has gone down very much in the list. 5 of the top 10 risks of mortality worldwide are associated to diet. Today, this greatest contributor to death, disability, and chronic disease is what we eat. Now, when does this obesity and overweight start? And I've been using this analogy of the lay press now for almost 20 years. We were concerned about how much adults were becoming overweight and obese, but it was clear that this problem started much earlier in life than just being obese as an adult. And then it has become even more clear that it is not just in infancy, but in fetal life that obesity and overweight begin. Now, when we look at the results of the obese parents, and I include fathers, but when we look at the numbers of mothers with obesity, their offspring will have an earlier time of death. So if you look at those curves, the curve of obese mothers, obese maternal BMI, there is a earlier time to death at between 60 and 70 years of age compared to people born to mothers with a more normal BMI. Excessive weight gain in pregnancy is associated with increased fat mass on the left. So mothers with excessive weight gain during pregnancy will have their neonates will have an increased fat mass. And at 6 years of age, they will continue to have an increased fat mass if their mothers gained too much weight during pregnancy. This is for any level of BMI. And when we look at the maternal pre-pregnancy BMI, this correlates with the risk of obesity in childhood and later on. So mothers who have a normal BMI today at a global level have an increase in overweight and obese children of about 14%. Mothers who have overweight during pregnancy, they increase their risk to about 36% of children becoming eventually overweight and obese. And mothers who are obese will have about half of the children who become overweight and obese later in life. So this problem starts, in fact, during fetal development. But then the first few months of life also become critical. When a child gains too much and their BMI score increases in the first 9 months of age, that's the x-axis, they will have a higher level of BMI at 9 or 10 years of age. So the first months of life, in this case, 0 to 9 months of age, it correlates with obesity, BMI, and adiposity after 10 years when the child is already 10 years. So these first months absolutely become critical. And today it's very clear we can predict the chances of obesity by the time the child is 2 years of age or less. Now, there are many factors that are associated with this development of obesity. And the truth is that in the end, right? Whether it's the individual factors the child is born with or the environmental factors that lead it to an inadequate food intake. Really, there's no magic here. If a child gets more energy and protein than they need based on their metabolism and physical activity, they will increase their body fat. That is the physical and chemical fact. The question is, what drives this increased need of food intake and modifies the internal factors of the infant to eventually develop obesity? And when we talk about the influence of these factors, any of those, it is absolutely clear that the impact is going to be higher the younger the child is. And this has led to the concept of early programming, meaning what happens in these first 2 years of life becomes the cause or the main reason why we will have health problems later. And the concept of the first 1,000 days, that is the addition of the time of pregnancy and the first 2 years of life, which adds up to 1,000 days, clearly it programs the child in many ways immunologically, sensorily, and developmentally to lead a more or less healthier life. And today, metabolic programming of the child in early life becomes critical to determine what the child's body composition, growth, and risk of chronic disease will be. Now, the first few years of life, especially the first 6 months of life, should be driven by the diet of an infant who breastfeeds. And it is clear that breastfeeding reduces multiple types of risks. Obviously, infectious disease is one of the best documented, but we have increases in metabolic disease and in immunologic disease associated to breastfeeding. And it is clear that compared to breastfed infants, formula-fed infants always have had a higher level of energy intake and protein, and they will have a higher weight for length when we compare children receiving almost any type of formula compared to breast milk. Breastfeeding reduces the risk of overweight and obesity compared to infant formula. This means infant formula increases the risks. So the blue bars are children who only who were never breastfed and received infant formula, and the yellow bars, children who had even small amounts of breastfeeding. Clearly, overweight and obesity are going to be higher in formula-fed infants. And the duration of breastfeeding in the x-axis, the more and the longer a child breastfeeds, the lower will be the risk of overweight and obesity, in this case, in this study, by 6 years of age. Long breastfeeding duration is associated with a lower risk of overweight in later life. For children who breastfeed less than 1 month, the risk of overweight is not different than children who are formula fed completely. For children who are breastfed 4 to 6 or better 9 months, there'll be lower risk. Roughly, each month of breastfeeding has been associated with a 4% decrease in the risk of overweight and obesity. So, if a child with formula is going to have metabolic problems, how do we find a substitute and how do we produce the best substitute for the child who doesn't get all the benefits of breastfeeding? And historically, we've used milk from other mammals, and by far, cow milk has been the most used milk to provide a substitute. Now, the development of breast milk substitutes these attempts. What we are doing is to adapt the milk of one mammal species to another mammal species like Homo sapiens. The problem is that every mammal milk is different. And just looking at very simply, when we look at the composition of milk, the first thing that is evident is that the protein of cow's milk is significantly higher, about 3 times as higher than the protein concentration in human milk. Not only that, but the composition of cow milk and human milk both contain different types of protein, including different types of casein, which is the protein that coagulates when milk gets acidified in the stomach, which is where we get curd and cheese, and whey, which is the soluble component of milk. Cow milk has 80% curd, 80% coagulated casein, and only 20% whey. Human milk is the inverse. It has much more soluble whey, which is easier to digest, and less percent of casein. So what we've done artificially in the late 50s and 60s is to develop formulas where we take the casein and the whey of a cow and we redistribute it to have it higher concentration of whey and less concentration of cow casein. It is also important to understand that the higher the concentration of whey protein, the higher the nutritional quality of the protein. When we look at the nutritional quality of whey or casein or soy protein, which are the most commonly used proteins for infants and is including protein in infant formulas, the essential composition of fatty acids, the utilization of protein, so how much protein is retained by the individual, the biologic value, so how much nitrogen is retained and absorbed, and the efficiency of the protein are all better with whey than with casein, and the last is soy. From this point of view, whey offers a higher nutritional quality of proteins for infants. So what we have done is to take the milk of one species and try to feed it to infants, and that has clinical consequences. Obviously, when we just give plain cow milk, raw cow milk, we had in early years, major microbiologic problems, major digestive enzymes. The phosphate concentration was too high, the osmolality was too high. Then we learned to boil milk. Actually, when you boil milk, you're going to have less infections, and you're going to begin hydrolyzing protein with the heat of the cow. So that will also improve the tolerance, and we learned this before, the 1900s. In the 1940s and 50s, we began using evaporated milk. So we take milk, add water, add sugar to the water and oil to make what we used to call formula in the 1940s and 1950s. But this, of course, was still very intact, high concentration of protein, which gave a lot of digestive intolerance. And for those who may remember, we used to have lactobezoars in babies that would get cow milk and evaporated milk in the, more than 50 or 60 years ago. And then eventually we took that protein and we modified the amount of cow whey and cow casein to 60-40 or 70-30. And that, no question, improved the tolerance of the child, gave more whey protein, and improved the amino acid profile. The problem is that while we made this concentration, we still understood there were other things that were not improving. And over the last 20 years, it has become increasingly evident that high protein intake is associated with a higher risk of obesity across the board in infants, in children, and to some degree in adults. And today, when we look at the protein intake of infants in the first 2 to 4 years of life, the yellow is recommended dietary allowance, and whether it's in the US, whether it's in China, whether it's in Europe, across the board, almost every population of infants and children is getting much more protein than the recommended dietary allowance for infants and children. And clearly, this has consequences. Higher protein intake in infancy is associated with a higher fat mass. And when we look at infants taking breast milk, or a high protein content formula above 2 grams of protein per 100 calories, or a lower protein formula closer to 1.8 grams per 100 calories, children with lower protein will have higher fat mass. They will have lower weight gain. Higher protein formulas increase weight gain and BMI at 2 years of age compared to breastfed infants. All the way to 6 years of age, higher protein formulas will risk overweight and obesity eventually in older children. And when we take at 6 years of age, children consuming higher protein formulas will have an increase in BMI and more than 2 times the increased risk of obesity. Excessive protein intake is associated with formula in infancy and childhood, contributing to obesity risk in later life. And as we said before, the basic problem is that we have not only given cow protein, but we've given more protein than babies need. And when we look at children, including toddlers, getting regular cow milk, they will be getting very large amounts of protein. We don't know all the mechanisms, but the best proposed is what we call the protein hypothesis. An excess protein intake will increase all circulating amino acids, but it will also increase insulinogenic amino acids, which will increase IGF-1, insulin growth factor 1, which will promote weight gain in early life. And the consequence of that, of course, is going to be metabolic syndrome. As we said, an increased weight in the first few months of age increase the risk of metabolic syndrome and eventually obesity. When we look and compare what children get, this is roughly the protein content in grams per 100 calories of human milk in the first 12 months of age. On average, about 1.8 grams per 100 calories. This protein content, of course, changes over time and adapts to the need of the growing infant. Historically, however, we have given infant formulas with a much higher level of protein. And the reason was to compensate for the fact that cow milk has a lower nutritional quality than human milk. And when we look at the amino acids that we provide, cow's milk protein is, of course, very different in terms of amino acid composition than human milk. On the top, you see those arrows are insulinogenic amino acids. Problem is human milk has a deficiency of tryptophan. Cow milk has a deficiency of tryptophan compared to human milk. So we have to give a higher amount of total amino acids so that we cover the needs of essential amino acids because the quality of the protein is not the same. So when we look at human milk and we look at threonine and tryptophan as two marker amino acids, the child is getting not only what is even in the milk, but that is what the child's needs are, and they're covered. When we give cow milk, we give a deficiency of tryptophan, which is an essential amino acid. So we have to increase the amount of protein so that we give the child what it needs, but this leads to an oversupply of total protein content. What has been done in the last 10 or 15 years is that we can now modify the protein quality of cow milk and take out a fraction, which we call casein glycomacropeptide, and increase the total amount of alpha-lactalbumin, which drops the threonine levels, so there's no excess, and increases the tryptophan levels, so now a child can get all the essential amino acids that they require. And when we compare this optimized protein, we can reach an improved level of amino acids, and therefore we can reduce total protein without sacrificing the proper balance of amino acids. So in this slide, a lower protein formula of about 1.8 grams per protein per 100 calories, you see there's a decrease in the light blue bars compared to the higher protein formulas, which are the blue bars, showing that we can continue providing adequate nutrition, but decrease the total content of protein. And when we look at amino acid grams on the left, you see the percent difference in insulinogenic amino acids. The pink dot in the middle is the healthy infant who is breastfed. The red are higher protein formulas, higher amounts of amino acid, and the blue or green bring it closer to the level of amino acids in human milk, not only for insulinogenic, but for all amino acids in general. And we look at children, the plasma amino acid content of insulinogenic amino acids with lower protein formulas, that is the green bars, it decreases these insulinogenic amino acids compared to the red bars, being it closer to human milk. And when we look at weight gain with lower protein formulas, we can see there's a slight reduction while we maintain adequate length and head growth. So children can safely receive a lower protein formula without sacrificing nutrition and essential amino acids. New technology then is allowing us to bring a lower amounts of higher quality protein, which is more in line with nutritional requirements and still yields an adequate growth. Today, we are improving milk not only from the nutritional point of view, but from the functional point of view, providing an optimized amount of protein in quantity and quality that improves metabolic outcomes compared to where we were just 10 or 15 years ago. So to conclude, of course, breast milk remains that model that inspires the way that we should be feeding children and should be supported and promoted. The feeding choices in the first months of life have long-lasting transgenerational effects, not only on nutrition, but especially on health. And today, higher protein intakes have been clearly associated with an increased weight gain and high BMI in early life, which increases the risk of obesity. And formulas have continued evolving to decrease those risks that are associated when a child is not given human milk. Advances in technology can help decrease these protein excesses by optimizing protein quality. This reduces protein concentration while maintaining adequate nutrition and amino acid delivery. And this can reduce this risk of obesity, overweight, and chronic disease later in life. And today, for children who are beyond the stage of formula, then limiting excessive cow milk intake after 1 or 2 years of life also may prove beneficial. Thank you for your attention.